Hi guys, Mr. T here, and today we're going to be just doing several examples talking about practicing with function notation. Let me slide myself a little bit further out of the way. Okay, so just going to try to go quickly as I can through several different examples on how function notation works. It's not that you're a novice at doing this, but taking it through several more examples. Okay, so I'm going to try to go through quickly. You can always rewind if I go too fast. Okay. All right, so here's our first couple examples. I probably am gonna, is that gonna work? We'll see how that works. Okay. All right, function notation. So we have four functions here. Okay, and they have different names, F, G, H, and J. Okay, and so what we're gonna do is practice just using the notation to do some different things. We're gonna substitute different values for other things. So anytime I see f of x, I could use 5x squared. Anytime I see g of x, I can use x plus 3 in its place, substituting. And we're going to get a little fancy with it a little bit, okay? So what we have here is, for our first little example here, we got f of x plus g of x. So what is, so I'm just going to rewrite this as I got f of x plus g of x. Those are just spots that I got to fill. So what does f of x equal? Well, that's 5x squared. Okay. What does g of x equal? That equals x plus 3. Okay. Easy enough, right? That's very interesting. Well, I just noticed something I'm probably going to have to edit on a different slide here in just a minute, but don't pay no attention to that. We're going to move on with this right here. Now, can we simplify this any further? Are there any like terms or just adding? No. So what I will do though is I'm just going to rewrite it one more time. 5x squared plus x plus 3, and then give it a big circle. And so that's it. We're not solving for anything. All we did was add these two functions together, and that's what we got. Okay, what happens if we subtract them? Well, it's going to be a very similar concept, right? So we got f of x minus g of x. And you got, I'm trying to get you to think of, these are spaces to be filled with stuff. And we're just going to go with whatever that thing says. We're going to stick it in the blank, okay? And it's not that big a deal right now, but it gets to be a bigger deal later, okay? So what does f of x equal? We look over here, it says 5x squared. And g of x is equal to x plus 3. Okay. Oh, but this is a little different. We got that negative. So that, does that negative only affect the x? No, it affects everything in the parentheses thereafter, because that says the opposite of g of x. The whole thing is opposite, right? So now we got to go a little further. So I bring down my 5x squared, and that turns that into a negative x, and then that turns that into a negative 3. Don't have any like terms, so we're all done with that. So that was a little different. We did have to do something about that situation. So adding a couple of functions, subtracting them, very similar, but we do need to distribute the negative sign because it affects the whole thing. All right, a couple more examples here. All right, what if we multiply? Okay, so let's just, same idea here. We got something times something. And what's in these two deals right here? So you got f of x. So in this case, f of x is 5x squared. And f of x is still 5x squared. So now we just do what it says. 5 times 5 is 25. And x squared times x squared is x to the 4th. Okay, so there's multiplying two functions. Now let's try this division of two things. So again, I'm going to try to get you to think, show you what you should be thinking. I got something divided by another something. Okay, that is what we're thinking when we're seeing this. Okay, so all right, what's up in this top section? F of x. What can I substitute for f of x? It says 5x squared. So I got 5x squared in there. Now it says g of x. Okay, that's x plus 3. There we go. Now, can't really do much with this. I said, well, what about the could we cancel those x's? Well, this is multiplication, that's addition, not going to happen. That's done. We are finished with that guy. He is now I could rewrite it without the parentheses, but other than that, we're done. Now, if I could factor it and simplify it further, I should, or do any other things I could, but I can't in this case. That's all I'm doing. It's just plugging it in. We're just practicing with that. Okay, let's try another example here. It's a little bit different. Okay, so these two guys seem very, very similar, but they are not the same. So I left some space up on top here because I want you to understand. Okay, this is f of 5. What do I see when I think of f as something? I think f of blank equals 5 blank squared. Okay, so over here on the left, I put an x in here and an x goes there. Is that what that says? Sure does. So when I see f of 5, what's that going to do for me? Well, I'm going to see the x goes there, the x goes there. So now the x disappeared and now I substituted a 5 in for the x. So what goes there? A 5. Okay, so that's 5. Whoops. Wrong color. Let's go. Okay, it didn't catch. 5 something squared. So x goes there, but what goes in that spot? In this case, it is a 5. Okay, so whatever's there goes here. Whatever's here goes here. It doesn't matter. What if I put a triangle here? Well, I'll put a triangle there. Now, I don't know what triangle squared is. Maybe it's a star or a hexagon. I don't know. But that's not the point. Whatever's in this parentheses goes in this parentheses, and then you do what you can with it. You may not be much, but you do what you can. All right, so that's what's going on with f of 5. And what about j of x? That's pretty much the deal, right? So we're just going to bring in j of x, which is x minus 3. Okay, so plus x minus 3. So that's all we got going on for that for the moment. So let's simplify this guy here. So 5 times 5 is 25. So that's going to give me 5 times, then we got plus x minus 3. So we said that's 25. Then 5 times 25. So 5 quarters is $1.25. So there we go. So now we got $1.25 here plus x minus 3. Okay, let's try the highlighter. There we go. We notice that these two guys right here are like terms. And we add and subtract like terms, always, 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 never unlike terms. Okay, so that these are like terms, so we can combine them. Let's see if I can get the pen to turn back on. Sure enough. Okay, so here we go. We got x plus 125 minus 3. That'd be 122. And there you go. So x plus 122 is what f of 5 plus j of x looks like. Okay, so when you plug a 5 into the f and then you add it to the j of x, that's what you get. Okay, all right. So there's a little division here. All right, so what are you doing there? So what's going on here? So this is what I'm seeing here. I got a negative 5 times something plus something else. Okay, so what can I substitute in this spot? It says f of x, which is equal to 5x squared. So I'm going to put 5x squared in there. G of x, what does that equal? Well, that is x plus 3. So I'm going to make that x plus 3. Okay, so we put the f of x here, the g of x there, and now we're just going to simplify what we can do. Just follow the instructions of the math. So negative 5 times 5x, well, that's going to give me, let's put green here, negative 25x squared. Okay, and then just plus x plus 3. Any like terms? No. So that's the deal. That's what you get. That's what happens when you do negative 5 times f of x and then add g of x to it. That's what you get. Okay? All right. I think I got one more I want to show you. Whoop. Two more. Sorry. All right. So this is going to be a little bit more interesting. Okay. A little bit more interesting. So let's start up here with h of something equals 2 times something squared minus 6 times something minus 20. Okay, all I did was write the h of x, but I wrote a bunch of blanks because, again, I'm trying to get you to think that way. Now, in our new problem here, I'm going to get real fun and make this 1/3. Everybody loves fractions, right? Fractions are our friends. And I'm just going to put a little simple x in for j of x, okay? So we're going to leave that part a little simple there. All right, so what's going on here? So normally we had an x in all these three places, right? So, but now what's in here? Instead of an x is a 1/3. It's a 1/3. So what goes into those blanks? 1/3. 1/3. That's what you do with that, okay? But I don't know. I don't care if they say H of a gorilla. Well, you better put that gorilla and square it and put that other gorilla in that other spot and then worry about what you're going to do with the gorilla later. But put them in the parentheses and then worry about it, okay? So whatever it says, you do it and then you start to worry about that other stuff. So that's what we're doing. What was in here gets put into those places. All right, so I'm just going to bring that down here and then start simplifying, okay? So we got 2. So what is 1/3 squared? Well, that is 1 times 1 is 1. 3 times 3 is 9. Okay. Then minus 6 times 1/3. Okay, there's not much going on with that, dude. Then minus 20. And I'll tell you what, I'm going to put plus j of x. Now I'm just going to leave that alone for just a second here. We'll train that out in just a second, which that's going to be x minus 3. Let's finish simplifying this side first, okay? Holy cow, what in the world is all this going to be? So this is going to be 2/9 minus 6. So that's going to be what? 2. 6 divided by 3 is 2 minus 20. Woohoo! Then let's make this plus x minus 3, which is what j of x is. Wow, all right, so I'm going to get fancy and do some cheating here, okay? I'm going to grab my calculator. And so I'm going to do 2/9 minus 2 minus 20 minus 3, okay? So I have a fancy calculator, and I'm going to use it, okay? So we said that was 2 over 9, kick out over there. And then we said that was minus 2 minus 20. And I believe we said the other one was, yes, minus 3 as well. Okay. And then I hit enter. And looky there. Isn't that a beautiful fraction? Negative 223 over 9. Who cares? Negative 223 over 9. Okay. So all of that mess right there turns back into negative 223 over 9. And then what? You got an x out front. So x, and then when you simplify all the like terms, that's what you get. So h of 1/3 plus j of x equals x minus 223 over 9. Okay. All right. One last deal here. Okay. One last deal. So what we're going to do is something called a composition of functions. We're going to put one function instead of the other. I want to warm us up a little bit here. Okay. So we start off by thinking f of g. Excuse me. Oh, excuse me. That's supposed to be g of x. This is the part I told you a while ago that I had written wrong. So just a moment. Bam. Video magic. Fixed it immediately. So here we go. I got it all fixed now. So let's look at this. Let's go back a little bit. G of x. Well, that was g of x and then x plus 3. So we plugged an x in both of those places. And then we advanced to putting in a number, right? So like g of 5, and then we put a 5 there, okay? So whatever went into that blank went into that blank. Now we went that, and that would end up being 8, okay? But what about this next situation? Our next one is going to be g of, let's look at it this way, of f. G of f of x is what they would say. Well, that's kind of weird, but I remember what I said about triangles, gorillas, don't care. Whatever goes here goes there. So I'm going to do that. I'm going to write f of x in this blank. And don't worry about anything else until I get it written. Now that I have written it, I can think, all right, can I substitute anything in for this? Okay, well, I still have something plus 3 here, right? So is there anything I could take f of x out and then put something like it in? Sure. F of x is equal to this thing next to the equal sign. And I'm going to put, see, what that is goes into that spot. And don't be worrying about we're taking x out, put another x in. Don't be thinking that. It just simply, whatever's here goes here. And that equal sign says anytime you see this symbol, I can put those symbols in their place. It's substituting one thing for the other. Okay, that's what you need to be thinking. Nothing, none of that other stuff. Okay, so I'm going to put a 5x squared here. Okay, because what goes here goes there, and I hear that and I saw over here to this thing that says they're both equal, so that's a legal move. All right, are these like terms? No, they are not. So I got 5x squared plus 3, and that is what you get when you do g of f of x. So when I put f of x inside of the g function, this is what I get. Okay, so it goes back to the same idea. Whatever's in there, you plug in, and then you just deal with the collateral damage, whatever that is, and go as far as you can. You may not be able to go very far at all, but just go as far as you can. But don't worry about it till you've done it. So there's practice with function notation. And as always, I hope it's helpful, and have a good evening.